Hello guys, in today's video we are looking at on how to find area between two curves, and we have been given this question, which is find the area enclosed by the curve y equals 5 plus x minus x squared and the line y plus 4. Here we're asked to find the area enclosed by the curve and the line. So let's get started. For you to find the intersection of this equation here, for y equals 5 plus x minus x squared with the y equals x plus 4, it is by equating this equation to be equal to this one here, because here we have y and here we have y. So where is y, we substitute with this one here, okay, in which we are going to say 5 plus x minus x squared, which should be equals to this part should be equals to this part here, which is x plus 4. We have substituted where there is y here with the x plus 4. Okay, so now here, if you can see, we have to correct the right term, in which we are going to say 5 when 4 crosses the equal sign to be minus 4 plus x, and when x crosses the equal sign to be minus x, then minus x squared, okay, in which this x and this x goes, because x minus x it is 0, and 5 minus 4 it is 1, so 1 minus x squared, which should be equals to 0 here, should be equals to 0, okay. So if you reach here now, this is where x squared will cross the equal sign, in which it will be x squared to be equals to 1, then x squared equals to 1, so we produce the square root both sides, plus or minus, in which x it will be equals to minus 1 plus 1 or minus 1. So this is the point of intersection, and now we have to find the y intercept, where that curve cuts y axis, okay, in which we can just say from this equation here, from this equation 1 here, which is a curve, we can say when x equals to 0, in which to be y equals to 5 plus 0 minus 0 squared, in which to be equals to y equals 5. So this is where the curve to cut the y-axis, and for this equation here, when x equals to 0, it will be x equals to, or y equals to 0 plus 4. So that means y equals to 4. So this line, it will be cutting y-axis at 4. So let's try to draw the graph here, the curve which we are looking for, the curve and the line. So we are going to draw like this. Don't mind my drawing. So let's say we are going to draw like this here, then this is where 4 is, and this is where 5 is for y, okay, and x here, and this is where minus 1 is, and the here 1 for x-axis, okay. If you can see from our solution, we will find that x it is equals equals to, we have found that this curve and line intersect at 1 and -1. So we have to draw the curve. The curve, this is a curve, is going to cut the y-axis at 5. This is 5 which we have found here. To come down like this, then to here, okay? Then remember that there is a line of y equals to 4. So y equals to 4, it is here. This is a line where y equals to 4. And the intersection, we have -1 and the 1 here. So we have -1 and the 1 here. So this is how this curve it will look like, okay? So since we have found the limits -1 and the 1 here for this equation, so now let's find the area under this curve here, okay? So this is this curve, it is y equals 5 plus x minus x squared, and this line here, it is y equals to x plus 4. So now let's find, since we have found the intersection of this curve and the line, this is the intersection here where this curve meets the line of this equation. It is -1 and the 1 here. So now let's find the area. We all know that to find the area, we're going to use the integral, okay? In which we are going to say the integral of 1, which is the upper limit, then -1, then open bracket, then it will be 5 plus x minus x squared, close, then minus the integral of, because the curve and the line, they are using the same limits. So here we're going to have 1, then -1 here, then open bracket, x plus 4, close bracket, dx, okay? So if you can see here from this integral which we have written here, because this curve here, the equation for the curve and the equation for the line, it is using they are using the same limit. So we are going to only use the one this limit to all these equation, which is it is going to be like this: the integral of 1, which is the upper limit, -1, then open bracket, it will be x plus here it will be 5 plus x minus x squared, then minus x plus 4, then close bracket, dx. Why have I written like this? Because this curve here, it has this limit which is same as this limit, so that's why we have just factorized it to this state here, okay? So now let's try to create a space here. So now let's find the area from this thing which we have here, in which we are going to cancel x minus x, it is 0. We are going to remain with 5 minus here, this minus it will multiply with this one here, which is in the bracket, so it will be going to be minus 4. So 5 minus 4, it is the integral of 1 minus 1 open bracket, then 5 minus 4, it is 1, then minus x squared, then close bracket dx. Okay, I guess you're following me here. Here, where this negative 4 comes from, because this negativity is multiplying what is in the brackets. Okay, so we have this integral here, which is the upper limit 1 minus 1, then open bracket x, 1 minus x squared dx. When we integrate this expression which we have here, we are going to have when you integrate 1 here, you're going to have x minus you're going to have x power 3 divided by 3. Okay, because we are adding the power here, we are integrating, so it will be plus 1 here, then you divide by the same new power, which is 2 plus 1 here. Okay, in which it will be x power 3 over 3. Then we have this limit here, which is 1 and the minus 1. So now let's substitute from this expression which we have here with the this limit which we have been given here, in which it will be the first one, it will be when you substitute x with the 1, we're going to have 1 minus a, where this x minus, or not minus, here 1 cubed over 3, then close bracket, then minus open bracket x, or where the x we substitute with the negative 1, so minus 1, then minus open bracket minus 1 cubed over 3 close bracket, in which it will be equals to 1 minus 1 cubed, it is 1 over 3. Okay, minus open bracket and minus negative 1 cubed, you are going to have negative 1, negative times negative, which is positive, so it is going to be 1 plus negative 1 plus 1 over 3, the bracket, in which here you are going to find the common denominator, which is 3 here. Okay, 1 into 3, 3 times 1, which is 3, minus 3 into 3, 1 times 1, which is 1 here, in which here you're going to have minus open bracket, then here you start with the this positive 1 here, which is 1 over 3, then minus 1 over 1, then close bracket, you are going to look for a common denominator, which is 3 here also, then 3 into 3, which is 1 times 1, which is 1, minus 1 into 3, which is 3 times 1, which is 3 here. Okay, so our equation, it will be like this, it will be like this, 3 minus 1 over 3, the bracket, then minus open bracket 1 minus 3 over 3. Okay, in which it will be equals to 3 minus 1, which is 2 over 3, then minus the bracket here, then minus open bracket 1 minus 3, which is negative 2 over 3. Negative times negative, which is positive, so in which it will be equals to 2 over 3, then plus 2 over 3, which should be equals to When common denominator are same, you just add, when numerator are equal, you're just going to add the denominator, which is 2 plus 2, which is 4 over 3. Take it into mixed fraction, it will be equals to 1. 3 into 4, which is 1, remainder 1 over 3 here. So it will be equals to 1 whole number 1 over 3 unity square, because we are finding the area under this curve and the line. Thank you for watching, and don't forget to subscribe and turn on the notification bell so the next time you see the video. See you next time. Bye bye.